Hello, my lovely students. So now we're taking a look at section 4.3. This is more formulas that you might on occasion use. The double angle formulas actually do get a lot more use than the sum and difference, although we get the double angles from the sum and difference, because if you just change it from alpha and beta to just theta and theta, these are the formulas you're going to get. So sine 2 theta is 2 sine theta cosine theta. Straight up. Cosine 2 theta, the direct result from the formula is cosine squared minus sine squared. But if I use the Pythagorean identity, sine squared plus cosine squared is 1, I can get these other two. So we usually give you like all of that. And there's even a formula for tangent 2 theta. Not that we use it that often, but hey, it's there. So down here, our first example, they've told us that tangent of theta is negative 3/4 and theta is in quadrant 2. And they want us to find the sine, cosine, and tangent of 2 theta. Okay. So let's start. If they tell you a quadrant, draw the triangle. All right. That is technically theta, but this is our reference angle. So, Soka-toa, or some old hippie caught another hippie tripping on acid. So this is tripping on acid. So negative 3/4, well, let's assign the 3 and the 4, 3 to opposite, 4 to adjacent. And then in this quadrant 2, the adjacent side is the negative side. So we're going to put that minus on the 4. So even though it looks like it's with the 3, when we draw it in the quadrant and think about where negative x's and negative y's are, that's where it makes sense. Now, in order to answer any of this, we're going to have to know what sine and cosine and, well, we have the tangent, are. So we need that third side. So it is the hypotenuse, we will call it C. So 3 squared plus negative 4 squared equals C squared. Notice the parentheses. So 9 plus 16 is C squared. So we get 25. So C is 5. Hypotenuse is always positive, so positive 5. So I already have my tangent of theta, so I'm just going to fill in here what sine of theta is here. Opposite over some old hippie O over H. So sine is positive 3/5. And cosine is negative 4/5. All right. So our sine 2 theta. This is 2 sine theta cosine theta. And it's silly, but it is worth it to write the formulas every time because you get more familiar with them. You won't have to look at the formula sheet as often, so you can do problems more quickly, since time seems to be a factor on the tests for most people. All right, sine is 3/5. Cosine is negative 4/5. All right, so on the bottom, 5 times 5 will be 25. On the top, negative 12 times 2, negative 24 25ths. That is sine 2 theta. All right, now we need to do our cosine 2 theta. All right, so this is cosine squared minus sine squared. So negative 4/5 squared minus 3/5 squared. This is 16/25 minus 9/5 is 9/25 is 7/25. And that works out to be positive. All right. So I have sine 2 theta, I have cosine 2 theta. So we could just divide the two and call that tangent 2 theta, and it is tangent 2 theta. But since we're actually, supposed to be learning how to use things, let's use the thing. So tangent of 2 theta is going to be tangent theta over 1 minus tangent squared. So this is 2 times negative 3/4 over 1 minus negative 3/4 squared. All right, so negative 6 over 4 is the same as negative 3 over 2. And this will be 1 minus 9/16. So 16/16 minus 9/16 is 7/16. So we have negative 3/2. It would be divided by 7/16, so it'll be times 16/7. 2 goes into 16 8 times. Negative 3 times 8 is negative 24 over 7. And if I look, sine had the negative 24, cosine had the 7. The over 25s would cancel out. So we did indeed find tangent of 2 theta. But we could have just divided the two. All right. So cosine's positive. That means this is, and sine is negative. This is a quadrant 4 triangle. Our tangent was also negative. All right, number 2 here is asking us to establish the identity. So we have cosine to the 4th minus sine to the 4th. So let me put a little side bubble over here. If I have a to the 4th minus b to the 4th, this can be factored as a difference of squares. So a squared and a squared, b squared and b squared. One gets a plus, one gets a minus. All right, so that's how we can factor a difference of 4th powers. We get one is a difference of squares, which could technically factor more, and the other is a sum of squares. All right, so now I'm just going to write that same thing, but with cosine and sine. So this is cosine squared plus sine squared. Why does that sound familiar? And cosine squared minus sine squared. Why does that sound familiar? All right, so hopefully you've been doing enough identities that you remember that's one. And then our new identity, cosine squared minus sine squared, is cosine 2 theta. We have done the thing. All right. So I'll chop this so it's 3 short videos.